Welcome back. Let's finish off the notes now. My next quadrilateral here, I can see definitely complies with my rule 1E, which states that something is a parallelogram if the diagonals of a quadrilateral bisect each other. And it has and the diagonals meet at a 90-degree angle. So by 2B, this must be a rhombus. However, there's nothing to help it be a rectangle. We don't have any rule, we don't have either that all four angles are 90-degree angles or that the diagonals are congruent. In fact, we have the opposite. So this must be a rhombus. Let's look at the next one. Here, I can see that I have opposite sides that are congruent. So by rule 1B, this guy has to be a parallelogram. And I can see that all of my sides are congruent. So by 2A, this must be a rhombus. But if you look, we also have diagonals that are meeting at a 90-degree angle. So 2B would have worked as well as a reason why this is a rhombus. However, I have nothing to show that this is a rectangle. So he must be a rhombus, and it ends there. Now let's look at the next one. Here I can see that my opposite sides are congruent. So by 1B, we're a parallelogram. I can see that all four sides are congruent. So by 2. So by 2A, by the definition of a rhombus, this is a rhombus. And I can see I have a 90-degree angle here. Therefore, this would be 90 degrees because the opposite angles have to be congruent since it's a parallelogram. And these two have to be 90 degrees because consecutive angles have to add up to 180. So by 3A, by the definition of a rectangle, this thing is also a rectangle. Well, we've got that it's a parallelogram, a rhombus, and a rectangle. Therefore, he is a square. Now let's look at our final example. Here, I've got lots of ways I could show that this thing's a parallelogram. I could say that my opposite sides are congruent, so it could be by 1B. Or I could show that the diagonals bisect each other, that's 1E. Both of those would work to show that it's a parallelogram. This is a rhombus because all four sides are congruent, so it's a rhombus by definition. And we can say it's a rectangle because the diagonals are congruent. Therefore, it's a rectangle by 3B. Well, I know that it's a parallelogram, I know it's a rhombus, I know it's a rectangle, therefore he is also a square. All right, let's go back and look at some proofs now. I know you're thinking, oh, make me do proofs. So sorry, guys, it's good for you, I promise. Okay. Here, we're going to prove that EFGH is a rhombus. And they give me actually quite a lot of information at the beginning. I know that FG is congruent to EH. So if I mark that on my diagram, FG is congruent to EH. And I know that FG is parallel to EH. So again, those guys are parallel. And I know that FG is congruent to FE. So FG is congruent to FE, we know that. Okay, so this is all given. Well, the first thing I can say, I noticed that I have one pair of opposite sides that are both parallel and congruent. Therefore, EFGH is a parallelogram because we have one pair of opposite sides are congruent and parallel. Okay. Well, if that's a parallelogram, then a lot of cool things fall out of that. We now know that EF must be congruent to GH because it is a parallelogram and opposite sides are congruent in parallelograms. Okay? And we already know that FE or EF right here is congruent to FG. So I can say that FG is congruent to GH by the transitive property. Okay. And we can then go further and then say that EH is also congruent to GH if we really want to, also by the transitive property. Therefore, EFGH is a rhombus by the definition of a rhombus, because all four sides are congruent. All right, let's take a look at that rectangle proof now. Okay, I'm going to try really hard to shorten this proof because I'm looking at my notes going, it's really long. So, here we go. We are given in this problem quite a bit. We are given that the measure of angle K plus the measure of angle L equals 180 degrees. So look at that. That's K and L. Notice those are consecutive. I'm also given the measure of angle K plus the measure of angle J equals 180. So K and J add up to 180, also consecutive. And the measure of angle K equals the measure of angle L. Well, so those are all my givens. I can say that angle K and angle L are supplementary, and angle K and angle J are supplementary, because that's the definition of supplementary. Okay, because they both add up to 180. Therefore, if you look, I've got one angle here, and it's supplementary to its two consecutive angles. This must be a parallelogram. So JKLM is a parallelogram. There's a really long word. Okay, and we say it's a parallelogram because one angle is supplementary to both of its consecutive angles. Okay? So if it's a parallelogram, things get really nice from here, because what I know now is that opposite angles are congruent. So I can say that angle J is congruent to angle M, and angle J is congruent to angle L. What am I doing? To angle L. And angle K is congruent to angle M by the definition, because opposite angles in parallelograms are congruent. We also know, therefore, that their measures are congruent. Measure of angle J equals measure of angle L. Measure of angle K equals measure of angle M. Definition of congruent. Now, I converted back into equals because I see I've got addition equations way up here that I'm going to have to use. Now, let's do some fancy math, shall we? Oh, wait. Let me see. Yes, I'm going to do some fancy math. Okay. Here, I showed, they gave me that K is equal to L. And here I have that K is equal to M. Therefore, I can, by the transitive property, say that the measure of angle L is equal to the measure of angle M as well. Does that help me? Probably. Just not there yet. I'll use it here in a second. Okay, and I'm going to come back up here to this. I'm going to plug into this. Measure of angle K plus measure of angle L equals 180, but I know that K equals L. Therefore, I can say measure of angle K plus measure of angle K equals 180. Therefore, we can say that 2 measure of angle K equals 180. Oh, I probably should put in reasons, shouldn't I? This is transitive, P of E, and this guy is substitution. Simplify. Therefore, measure of angle K equals 90 by division. Well, if you look, we've got everything else related to K in some way, shape, or form. I could go back up the chain and show that measure of angle J is 90, and I could show that the measure of angle L is 90, and the measure of angle M is 90, all by various versions of the transitive property. Well, now we've got that all the angles are 90 degrees, therefore, JKLM is a rectangle by the definition of rectangle. And I'm done. Thank goodness. That was a long proof. Yep. All right. Cool, guys. I think that's it. Fill in your notes. Make sure you're ready next class. Talk to y'all later. Bye.